Betelgeuse stands out as one of the most mesmerizing celestial objects visible in the night sky, not just because of its colossal dimensions and remarkable brilliance, but also due to the profound mysteries it presents about stellar birth, life, and death. Located around 650 light-years away in the Orion constellation, this red supergiant represents a late stage in the life cycle of massive stars. Its enormous size, several hundred times larger than our Sun, stretches the boundaries of our imagination. If Betelgeuse were positioned at the heart of our solar system, its outer edges would surpass Jupiter's orbit, enveloping the inner planets. This overwhelming magnitude, paired with its volatile and often unpredictable nature, has placed it at the forefront of astrophysical inquiry as scientists attempt to decode the cosmic recycling of matter and energy. In late 2019, the star experienced a dramatic dimming event, its brightness plummeting by nearly 40%. This triggered worldwide speculation that a supernova might be imminent. Although this event was ultimately attributed to massive dust clouds expelled from the star's surface, it rekindled global curiosity. These eruptions of gas and dust are part of Betelgeuse's continuous mass-shedding phase influenced by robust stellar winds and surface convective processes. Such eruptions are not just signs of the star's decline. They play a vital role in enriching space with heavy elements. Elements such as calcium, oxygen, and iron, key components of our bodies and environment, were born in the nuclear furnaces of stars like Betelgeuse and spread across space through such explosive outbursts. Despite the strides made in understanding it, Betelgeuse still guards many secrets. Scientists are now employing advanced techniques like astroseismology, which examines stellar oscillations, to delve into its inner workings. Sophisticated tools such as the Very Large Telescope Interferometer have unveiled previously unseen surface features like hotspots and turbulent gas currents. The James Webb Space Telescope, JWST, with its superior infrared sensitivity, is helping astronomers peer through Betelgeuse's dusty shroud, providing vital data on its thermal variations, expelled materials, and nearby surroundings. When Betelgeuse eventually goes supernova, the event will offer an extraordinary opportunity for science. Core collapse supernovae are among the most energetic and violent explosions in the universe, releasing in days more energy than our Sun will emit over its entire lifetime. However, many facets of these cosmic events remain elusive. Scientists continue to explore the exact mechanisms of core collapse, the influence of neutrinos in initiating the explosion, and the role of asymmetries in forming neutron stars or black holes. The eventual death of Betelgeuse will provide an unmatched natural laboratory to investigate these fundamental phenomena. Researchers across the globe are already coordinating, preparing a vast network of telescopes, neutrino observatories, and gravitational wave detectors to catch every hint of this future explosion. The first sign of the impending supernova will be a burst of neutrinos escaping from the core hours before visible light reaches Earth. Systems like the Supernova Early Warning System, SNOS, will offer scientists precious time to recalibrate instruments such as JWST, Hubble, the European Extremely Large Telescope, ELT, and the Varick-Rubin Observatory to fully capture the event from its onset. These international efforts promise the most thorough observational data set ever gathered for a dying star, transitioning our comprehension from abstract theory into tangible real-time phenomena. Yet, the explosion itself will mark only the beginning of Betelgeuse's concluding saga. The nebula formed from rapidly dispersing stellar debris will radiate for decades or even centuries, serving as a cosmic archive of the explosion's physical and chemical signatures. If a neutron star emerges from the wreckage, it will become a focus of study due to its intense spin, magnetic fields, and pulsar emissions. Alternatively, if a black hole forms, it would allow scientists to observe for the first time directly the formation of a stellar mass black hole. The aftermath of this supernova will bear imprints of the nuclear processes active in the star's final moments, yielding crucial insights into how elements are forged, how stars die, and how galaxies and life itself are born. While the scientific value is vast, Betelgeuse's emotional and cultural significance is equally profound. For centuries, humans across civilizations have looked up at Orion's red shoulder and built myths, legends, and narratives around it. The idea that such a familiar star could vanish within our lifetime evokes a deep emotional reaction. Once thought to be divine portents, supernovae are now understood as key steps in cosmic renewal. Yet, the awe and wonder remain. Betelgeuse's eventual death reminds us of our transient place beneath the stars, where even the brightest celestial bodies are not eternal. The atoms in our bodies once belonged to stars like Betelgeuse. So watching its end is, in a sense, witnessing the story of our own beginnings. Global preparations for Betelgeuse's supernova are extensive. Neutrino detectors like Super Kamiokande in Japan and IceCube in Antarctica are ready to detect early warning signs. Gravitational wave facilities like LIGO and Virgo stand ready to measure any space-time distortions across the electromagnetic spectrum. Telescopes spanning radio to ultraviolet wavelengths are on standby to capture the entire explosion timeline. Public enthusiasm has paralleled scientific interest. The 2019 dimming prompted widespread engagement across schools, social media, and astronomy clubs. When the star finally explodes, it could become one of the most widely viewed sky events in human history. Its brightness is expected to reach a magnitude between -10 and -12, possibly outshining the full moon for several weeks, and even remaining visible during the daytime. Such a display hasn't occurred since Kepler's supernova in 604. Yet, after the initial brilliance fades, the true scientific work will begin. The shock wave from the explosion will help map the structure of the interstellar environment around the star. The glowing remnants will reveal what kinds of elements were created, offering a long-term data set for studying the processes behind stellar death. Over time, this will help refine our understanding of red supergiants and how various factors determine whether they collapse quietly or explode dramatically. Should a neutron star arise, it will open a window into one of the most extreme known cosmic objects, where forces like magnetism, gravity, and rotation act in exotic ways. If instead a black hole forms, it may allow the first direct observation of one being born. Perhaps the most poetic aspect is that everything we're witnessing now happened in the distant past. The light reaching Earth today left Betelgeuse's surface around 650 years ago during the Middle Ages. If it already exploded, that light is still on its way. Thus, Betelgeuse acts as both a beacon and a time machine, linking us to the cosmos in an extraordinary way. This perspective is reshaping the emerging field of time domain astronomy, which focuses on short-lived dynamic events like supernovae, gamma-ray bursts, and gravitational waves. Astronomers must now be ever vigilant, ready to pivot at a moment's notice. Betelgeuse is training us to become more responsive observers of the universe. The challenges it presents are refining theoretical models. Researchers are using increasingly detailed simulations to study every step of a star's explosive death, from the core collapse to shockwave development and energy release. Some scientists even believe that the 2019 dimming may have been more than a dusty outburst. It could be the beginning of a slow, prolonged death. If so, we are privileged to witness the most detailed case study of a star's demise ever recorded. But Betelgeuse's legacy extends beyond science. Just like the Crab Nebula's origin in a supernova was captured in ancient writings and folklore, Betelgeuse will leave its mark on future generations, inspiring creativity in art, literature, film, and beyond. Ultimately, this star reminds us that the cosmos is a living narrative. When the stars speak, we listen. The growing network of collaborations between scientists, observatories, and amateur sky watchers demonstrates that the universe continues to unite us. Betelgeuse will leave more than a glowing nebula. It will leave a legacy of curiosity, cooperation, and wonder, bridging science and spirit in an unforgettable final act. Its supernova won't be a mere explosion in the sky. It symbolizes a transformative moment in modern astronomy and global scientific cooperation. Unlike past eras where celestial anomalies were